some weaknesses in containers are targeted by cryptominers.
Welcome, Kim. You have a story about actually misconfigured containers being used by malware for malicious purposes. Would you like to elaborate a little bit on that?
Aqua Security recently noticed that attackers are trying to set up crypto mining farms on Docker instances out there for containers. So what they're doing is that they are scanning the ports that are out there, constantly scanning on a hourly basis, whether it's daily or hourly basis, and they're looking for these open ports out in the cloud environments, which this is a misconfiguration, and this has been known to happen, especially with Kubernetes and their management of containers, and now with Docker. So this misconfiguration rather, with Docker has allowed hackers to be able to set up around a lateral movement on other machines within the same cluster of containers and inject malware there and set up crypto mining farms on the network. The Docker instances are, by default, are unprotected, is an unprotected port. So what happens is that a lot of administrators, rather, they don't know that they have no idea when they initially set up Docker or whether it's Kubernetes that there are open ports that are open to the internet, and they don't go back to look to see, it automatically sets up an ingress to their environment when you initially install. So this allows hackers to get in. I'm sorry.
Sorry, no, I just said, an open port on the internet, unprotected, and it is not a good thing.
Unprotected, and more so often it's ports 80 and 443 that are open. So this the Docker instances are the actual malware that they're injecting is called the Kensing malware, which is it's based off of Graboid, which was an initial malware for cryptocurrency as well. But the difference between the two is that this Kensing malware, they're using a legitimate image, whereas a custom-based image was used, or the OS image was used with the Graboid. So in order to get around the security ramifications of the companies, so normally companies have their own images, or say Ubuntu, or whether it's CentOS, whatever it may be. So to get around the security, this Kensing malware is setting up a legitimate image, installing it, and then downloading their script. It's a 600-line script that they download and run, and it pushes out or connects to the command and control. And it's 3 IPs that they use, rather, that they're using in the script. And so it's also scanning other containers in the cluster. They're scanning other containers so that it can check to see if the bash history and if it can connect on SSH to different ones, and that's how it goes laterally across the containers and injects the malware. And so they're not using the malware maliciously per se, even though it is malicious, or it's more so setting up these crypto miners, not to actually take down the servers in a way to take down the servers or denial of service or environment, but it does use a lot of resources.
Cloud instances can be incredibly expensive too.
Very.
So
yeah.
So it's a financially motivated attack because they want to put these crypto miners on these cloud instances, and of course they can make some money that way. But on the other end, the victim side, those resources could very quickly get into a very large number. So I think it's really important that when you're putting something in the cloud, even if it's just like a personal project or something, make sure that thing is secured. And I'll let you finish, but I want to ask, what can you do? Obviously, cloud computing is a big deal. It's going to become a bigger deal. It's kind of like a new frontier a little bit. I want to play with it. I'm sure other people want to play with it. They want to get involved. They want to see what it is. They want to see if they can use it for personal projects, or maybe you've got a business idea or something. What can you do to make sure that somebody doesn't put a crypto miner on your instance and rack up a bill of a couple $1,000s overnight?
Exactly. And so there is certain software out there that you can use in your cloud environment to scan your network, to scan your resources in the cloud, to check to see if there's crypto mining software out there. And another thing I want to bring up is that this Kensing malware, it tries to alleviate any other crypto mining malware that's out there that may exist on your cluster. So what happens is it wants to be the last man standing, rather. So it checks to see if any other crypto miners have injected into your cluster, and it just gets rid of all of those. But what you can do, and it's hard for some administrators that they don't know that the security ramification is there. So what you can do is to make sure that when you do set up your environment, that you go and check all of your security groups. Make sure that you're not allowing any ports that are open to your cluster, that the vulnerable ports are closed. Also, some of these IPs that they've suggested in the document here, you can automatically close those on your network security group so that those aren't allowed outbound, or to shut those down, or allow anything inbound that doesn't need to be there. Your load balancers or your ingress need to be shut down as well, or locked as to only allow what's necessary. And if possible, a lot of instances or cloud environments allow internet connectivity to their cluster. But if you can, you should set up your cluster as private only, and only do private ingress only. No external ingress to your cluster.
It's really interesting the amount of techniques it's using. The first thing is, if I understand correctly, Kim, they're trying to actually mimic a picture, like a regular picture, like a valid picture, to go through the securities, and they're trying to put the OS versions of it, right, just to bypass the security restrictions. And once they have, basically they're trying to get on the malware to the cloud instances, and they're starting their thing. One thing is, even if it's just a crypto miner, still they're causing some malicious damage to the customers, maybe the cloud environment in this case. The thing is, I think as far as the recommendations, I heard you said a couple of points. I think one would be watching your resources. In this case, any increased CPU utilization is a giveaway.
It's a safe assumption that if it's on the internet, it's going to get scanned. I think we can agree on that. And it's important. It's also important to understand that misconfigurations in the cloud, we've seen it a lot. We've seen it with S3 buckets, when a bunch of data was just sitting out there, and people, researchers or otherwise, would just come across them and say, hey, look, I have all this data that I just found. It's just sitting there unprotected. So, with cloud instances, there's a couple different ways to access them. Sometimes it's like through a console. If you're the admin, you can log into like an AWS console, and you can, do your administration that way. But a lot of it is key-based. You would connect to a service with a specific key, like an AWS key in that instance. So one vector that I would warn people about is, obviously you're probably writing code and you're probably using that code, and there's probably a key somewhere in that code so that you can authenticate to whatever cloud instances you're working with. Make sure you don't push that code that contains that key into GitHub, because then you can just go to GitHub and you can find that key and then connect to it. And that's something that's something that we see quite a bit. Unfortunately, if you go to GitHub and you just kind of look for an AWS key, unfortunately you'll find a lot there. So that's another recommendation I would make to folks who want to get into cloud computing. If you are working with code and you are pushing things to a GitHub repository, you're using version control, make sure it's either an environment variable or you've got something specific set up. Make sure you don't have a plain text key just sitting right in the code, and then because you might push it up. Some of these projects can have hundreds of files, and maybe you forgot to put it into git ignore and it ended up there. And then let's say it does get on GitHub and you delete it. It's probably in the commit history still. So make sure you actually delete it from the commit history. GitHub is designed to not forget things. Obviously, it's very important that it doesn't just forget things. You can't just delete something. So it's a little sticky. So understand that before you actually go in and commit stuff to it. But it's a good story, Ken. Thanks.
Yeah. Right. Thanks.